Welcome to the AI Brief, episode 277.
Wow, quite a week for AI hitting the real world, wouldn't you say?
Absolutely, we're seeing some major shifts. Things like Waymo robotaxis rolling into corporate travel.
And that new Google Robotics model that actually, well, thinks before it acts.
Plus that tiny inspection robot from China. It really feels like we've moved past just theory.
Definitely. So for this deep dive, we're going to try and piece together the big picture, geopolitics, and the deep science shaping the next few years.
Sounds good.
We got four main things lined up. First, South Korea putting AI right at the center of a global summit. Think AI diplomacy. Second, a huge science story. A 6,100 qubit quantum array from Caltech. Just incredible.
First breakthrough there.
Then third, a quick run through of other key AI and robotics updates.
The applied stuff.
Exactly. And finally, some top AI tools you can actually use right now to get more done.
Okay, that sets the stage nicely. You have this collision, right? Groundbreaking tech happening while governments are trying to figure out the rules. Yeah, and you really need to track both to see where things are going.
So let's start with those rules, maybe. That APEC summit sounds like a precedent setter.
It really does. South Korea is hosting the APEC CEO Summit in Gyeongju, October 2025. And it's not just another meeting.
No, the whole thing is dedicated to AI, high-level strategic discussions.
They're really leveraging the APEC platform, the Asia-Pacific Economic Cooperation, to boost their own profile in AI.
It's a smart diplomatic move. I mean, look who they've invited. CEOs from NVIDIA, OpenAI, Apple, Google, Alibaba, TikTok.
The guest list is basically the tech world's heavy hitters. Strong chance we'll see Jensen Huang, Sam Altman maybe leading panels.
And remember the context. This CEO summit isn't the main leader summit. It's a specific side event.
Right, designed to get, what, 200 or 300 global CEOs together.
Yeah, specifically to hammer out policy recommendations that then go straight to the heads of state. Real influence potential.
It's interesting, though, the strategy here. South Korea is clearly pushing its own tech scene. They've got visits planned to Samsung, SK Hynix fabs.
Showcasing their capabilities. And they're talking up their AI for all idea, plus this push for sovereign AI.
But that's where it gets tricky, isn't it? Sovereign AI suggests, national control, building local champions.
Keeping data secure, prioritizing their own needs.
Yet to do that, they're inviting the huge global players, Google, OpenAI, NVIDIA, who kind of dominate the field right now.
That's the balancing act. Leverage the big names to attract investment, but risk having global standards, maybe Silicon Valley standards, overshadow their sovereign goals.
So the implications aren't just regional. This could impact global trade.
Oh, absolutely. Hosting this elevates South Korea as a major AI policy player almost instantly.
And the recommendations coming out of Gyeongju.
They could seriously shape APEC-wide standards for years. We're talking trade rules, data sharing agreements, even AI ethics frameworks across the whole Pacific Rim.
That's a huge economic bloc.
Exactly. This is what AI-focused diplomacy looks like now. CEOs influencing regulations almost before the tech is fully baked.
Which puts enormous pressure back on the underlying technology itself. So let's shift gears from that high-level policy to the deep science.
Okay.
Because there's this foundational breakthrough in quantum computing hardware out of Caltech. A record-breaking 6,100 qubit neutral atom array.
This is one of those results that could genuinely speed things up, for quantum computing to hit practical quantum advantage.
Solving problems classical computers just can't handle.
Right. You need two things at once. Scale, meaning lots of qubits, and quality, meaning those qubits have to be incredibly stable and reliable.
And Caltech seems to have nailed both with this approach using cesium atoms held in optical tweezers. Numbers are pretty wild.
They really are. They got superposition coherence up to about 13 seconds.
Okay, break that down. Coherence is like the qubit's ability to hold on to information.
Sort of like its attention span, yeah. How long it can maintain that delicate quantum state before noise messes it up. 13 seconds is roughly 10 times better than previous neutral atom systems. Think of it as enough time to perform a really complex calculation without losing track.
And they combine that long attention span with really high fidelity, right? Single qubit operations were like 99.98% accurate.
Exactly. Getting that quality while scaling up to over 6,000 qubits, that's the huge engineering feat here.
So quality and quantity.
But maybe the biggest deal for practical quantum computing, especially error correction, is the reconfigurability they demonstrated.
Meaning they can move the atoms around.
Yeah, they can physically move these cesium atoms across the chip, hundreds of micrometers, while they still hold that quantum state for 13 seconds.
Why is moving them so important?
Well, useful quantum algorithms need complex connections between qubits, and building fault-tolerant systems, the ultimate goal, requires grouping many physical qubits into one stable logical qubit. Being able to dynamically rearrange the atoms is crucial for building those flexible, robust error correction schemes. It gives you options.
So what's this do to the overall quantum race? It felt like superconducting circuits, Google, IBM, and maybe trapped ions were the main contenders.
Well, now neutral atom platforms like this Caltech one are undeniably a top contender, a third major pillar.
Their scalability looks competitive now.
It really does. And some think the path to error correction might be less complex or costly with neutral atoms compared to the others.
So we might see fault-tolerant prototypes sooner.
Timelines are definitely being revised. Experts are talking maybe 3 to 5 years now for initial fault-tolerant systems that could tackle meaningful problems. This will absolutely influence where research funding goes.
Okay, huge foundational shift there. Let's move into our quick hits now, how AI is getting integrated into complex physical tasks right now. The theme seems to be AI moving from just reacting to actually reasoning.
That's a significant step.
First, Google's Gemini Robotics 1.5. This isn't just about faster robot arms, is it?
No, it's about teaching robots to think through a problem almost like a person would when faced with something new.
The example they gave was sorting recycling based on local rules.
Exactly. A typical robot needs those rules programmed in advance. Gemini 1.5 apparently can first research the specific rules online, like, is this black plastic recyclable in this town? Then plan the sorting, then actually do it.
Connecting online info to physical action.
That's the key. And apparently these learned skills transfer across different robot bodies.
Yeah, regardless of the design, number of fingers, whatever, it learns general principles, not just specific moves.
Yeah.
That kind of flexibility is huge for wider adoption.
Definitely. Okay, shifting gears to the business side, Waymo for Business.
Right, Waymo is taking its robotaxi service and aiming it squarely at corporate travel.
So companies in, 5 U.S. cities now can set up accounts for their employees to use Waymo.
And it's integrated, right? Budget tracking, reporting tools for the company.
Yeah.
It makes autonomous rides just another managed expense.
It signals a certain maturity, doesn't it?
Yeah.
Moving beyond just consumer novelty into being a regular enterprise tool shows the regulatory side is catching up too.
True. And finally, there's Skill AI. They're making a pretty bold claim about an omni-bodied robot brain.
Yeah, the claim is a single AI system trained on data from maybe 100,000 different robot types can control basically any robot without needing specific programming for that body.
And they highlighted resilience, adapting to broken parts or jammed motors.
That's the headline dynamic adaptation, trying to create truly general-purpose robot control.
Sounds almost too good to be true.
Well, let's inject a bit of caution there. A universal brain is appealing, but where's the trade-off? If it's trained on everything, it might be okay at lots of things.
But maybe not great at one specific highly optimized task.
Exactly. Does it match the precision you'd get from a controller fine-tuned for one industrial job? That's the perennial challenge with generalization versus specialization. It's a big step, for sure, but the real test is performance in demanding situations.
Good point. General purpose is exciting, but specialized often wins in industry. Okay, let's wrap this deep dive with some practical tools you can check out right now. Stuff designed to boost productivity, going beyond just the big chatbots.
Always useful.
First up, Flick. Aimed at simplifying social media growth. It bundles scheduling, analytics, and AI copywriting.
So it's trying to be an all-in-one for social managers, competing with tools like Buffer or Hootsuite, maybe.
Seems like it. But with a strong focus on the AI helping create the actual content, the ideas, the copy, tailored for social platforms.
That integration of analytics and AI creation could be really helpful if you're struggling to keep up with content demands.
Next, Scale Donovan. This one's described as a decision intelligence platform, built for fast internal team planning and action.
Aiming to speed up strategy. That's often a bottleneck in big companies getting data, debating, deciding.
Right. Scale Donovan tries to accelerate that by giving quick, data-driven planning insights.
Though you'd still need that human oversight, wouldn't you? Speed and strategy needs careful checks on the underlying assumptions.
Absolutely. Then if you deal with a lot of customer emails, EmailTree is gaining traction. It helps automate replies using your company's own knowledge base.
Ah, so it's not just a generic AI answering. It pulls from your verified internal documents.
Exactly. Should lead to faster, more accurate, and context-specific replies. Saves employees time hunting for answers.
Frees them up for the trickier customer issues. Makes sense.
And finally, Waxwing 2.0. This one's interesting, a human-assisted AI marketplace.
Human assisted. So it acknowledges AI can't do everything alone yet.
Precisely. Waxwing combines automation speed with human judgment for tasks that need that nuance. Think complex content moderation, tricky data labeling, maybe niche translations.
So AI does the bulk work, but routes the critical judgment calls to actual people.
That's the idea. Helps businesses scale tasks where full automation isn't reliable enough on its own.
That hybrid approach seems very pragmatic for where AI is today. Pulling all this together, the quantum leaps, the global policy moves at APEC, robots like Gemini starting to reason, there's a clear theme emerging.
What's that?
The groundwork, the actual foundations for the next computing era, they're being laid right now, simultaneously, across science, business, and politics.
We're not just talking about the future anymore.
No, we're actively building the scaffolding for it in all these different arenas at once.
That's a great way to frame it. Okay, so as you think about how fast all this is moving, here's something to chew on for the week. How does the ability of systems like Google's Gemini Robotics 1.5 systems that can reason and do online research before acting physically, how does that change what we even mean by skill or expertise in the job market?
If the robot can look up the recycling rules itself.
What's the new skill the human needs to bring? Something to think about. All right, that's all the time we have for this deep dive. If you found this useful, got some critical context, please follow the AI brief.
And maybe share this deep dive with someone else who needs to stay informed on these rapid changes.
We really appreciate you diving deep with us.